So let's start with what we need to write down. So today is day one on the guided note sheet. Tomorrow you will need your student companions. Okay? We're talking about arcs. So an arc is a thank you. It's a part of a circle consisting of 2 points on the circle and the unbroken part of the circle between the 2 points. Nice. Just the earbud, please. Okay, so the next part is the central angle. Is an angle whose vertex is at the center of the circle. So there's some nice little pictures there for you. And one thing that is awesome about these two is that, wouldn't you know it, if one is a certain degree, the other is that same degree. Not saying that they are congruent parts. That is not what it means. Because one is an arc and one is an angle. They just could have the same degree measure. Okay? Questions on that? Okay. So here's some information that is actually pretty substantial for you. So angle APB is a central angle, and arc AB is the corresponding intercepted arc. So here's AB. Now, when we name arcs, we are literally talking about the direction with those. So when I'm talking about arc A to B, I'm physically going from here, A to B. That is known as a minor arc because it is less than 180 degrees and it only needs 2 letters to name. We also have something called a major arc, though, and that is larger than the semicircle. So that means larger than 180 degrees. When you name a major arc, again, it's important that you draw what it says here. So we have arc A to C to B. So they're talking about this in yellow. If you flip-flop this B to C to A, it'll be okay. But if you mixed up the letters completely and did like A to B to C, that is a completely different arc. Okay? So be careful how you name these or how they are named, and make sure you are, if you're not seeing it, follow a pencil along so you understand. Okay? This intercepted arc means that the arc is cut off from the circle by a central angle. And then just a note here, a full circle is 360 degrees, a semicircle is 180. Major arcs are also always named by 3 letters. Anybody still writing? Caught up? Almost? Okay. Just finish up. Let me know when you're done. Good. McKenna, are you still writing? Okay. Anybody else still writing? Okay. So let's take a peek at this first example. So it says find the measure of arc AB and the measure of arc ACB. So again, if I drew from A to B, we're talking about that arc. Our central angle is 95 degrees. That makes this 95 degrees as well. Now, if we're talking from A to C to B, again, I'm starting at A, going to C, going to B. So this is going to be 360 minus 95 because that's all we have left, which gives us a total of 265 degrees. So now let's do a shout out for this try it. It says use circle W. So here's circle W. They want us to find the measure of arc X to Z. What's it going to be? Bless you. What's it going to be? Who's got it? Good. 115. Very good. All right, the next one they want is from X to Y to Z. So here's X to Y to Z. So this is going to be 360 minus the 115, which leaves us with how many degrees? 245 degrees. Very good. Questions on that? Okay. So there's some other things I want you to write down. I know I'm going to kind of reveal the answer to example 2, but that's okay. So here's an arc measure. So the measure of the arc is equal to the measure of its corresponding central angle. So they're showing you again this whole idea of the central angle equals the arc measure. Now, what happens? So congruent central angles intercept congruent arcs, and congruent arcs are intercepted by congruent central angles. So if we look at this, what they're saying is that since this radius, KP, is breaking this arc up into two congruent arcs, that means these angles right here will also be congruent, and vice versa. Okay? And now let's take a look at example 2. So it says find each measure. So if we look, we're looking for the measure of arc FE. So here's F to E. That's just 100 because its central angle is 100 degrees. If we're looking for BC, so this is the arc we're talking about, but we know it's congruent with AB. Now AB is going to be 50 because of that central angle, making this also 50 degrees. Now we're going to talk about CE. So here's arc C to E. Now we know the 90, but we don't have this. What do you think we're going to have to do here in order to find this part? Go ahead. Okay, so we're going to take three. Now remember, this is 50 also. So we know that. We know this is congruent with this, and we know this is 100. So we can take 360, subtract 90, subtract 100, subtract 50, and another 50. How many degrees are we left with? Yeah, 70. But we're dividing it by 2 because these are two congruent parts. So divided by 2, that leaves us with 35 total degrees. So in this case, so if this is 35, CE is going to be 90 plus 35, which gives us a total of 125 degrees. Questions? All right, let's talk CFE. So now we're going to look at from C going all the way to F, going all the way to E. All we need to do here is add up all these arc measures. We know this one is 35 based off what we just found. So this will be 50 plus 50 plus 35 plus 100. And that leaves us with a total of 235 degrees. Questions on this? Anything? Okay. Let's move on to the next page. So now we're going to solve for x here. So if we take a look, we see that A, B, C, and C, D, B are congruent. So if this arc is 44, that means AC is also 44. We see that AE is 158. And they want us to find 7x plus 9. So in this case, what we can do is I'm going to take 360 minus the 158 minus the 244s. And that gives me a total of 100, what did I get? I think that 114 degrees. And then I'm going to take this and set it equal to 114. So 7x plus 9 equals 114. Subtract the 9. That leaves me with 7x equals 105. Divide by 7, I get x is equal to 15. Questions on that? Try this one on your own. We'll go over it in just a second. No Lucy today, right? Just double checking. Okay, who's still working on the You Try It? Anybody? Oh, let's check out our answers. So you should have gotten 15 for X, 109 for AC, and 137 for AD. Or right here, I'm sorry. Questions on that? This is just another way of doing it. I usually just try to find it first. It makes it a lot easier. Okay, so recall circumference of the circle is the distance around the circle. So think of it as like perimeter. Circumference is the perimeter of a circle, all right? And it can be found using pi times the diameter or 2 pi times the radius. But if you do 2 times the radius, you get a diameter. So that's why either one works. So in this case, the measure of an arc is a fraction of 360. So we have this n right here, and we measure that in degrees. The arc length is a fraction of the circumference, okay? So we're not trying to find the amount of degrees this is. We're trying to find how, like if I took it and stretched it out, how long is that going to be? So this leads us into our next formula, which is measured in degrees. N degrees, so that arc in question, divided by 360 times 2 pi times the radius. Or you knew pi times diameter. It's completely up to you. Okay? And one thing they are saying about arc length, remember, it's a part of the circumference, so that should be in inches, centimeters, meters, feet, something like that. Okay, some unit of length. Show of hands, you're still writing this. Okay. So let's take a look at example 4. So looking like this, I have this radius, I have this arc. They want us to find the length of C to E to B. So I want us to find that length. So the first thing I'm going to do is I'm going to find that degree measure. I'm going to take 360 minus 132, which gives me a total of 228 degrees. Now I need to apply it to the arc length formula. But here's the thing. You guys see this right here? Pretty important. See how it says exact answer? So we've already talked about exact answers. We've seen a couple of them, right? One was fraction form. The other was simplest radical form, right? That's an exact answer. Same thing here. We're going to talk about in terms of pi. So when they ask you for an exact answer, that means you're just not going to multiply everything by pi. You're just going to leave it alone and put it in with your answer. Okay? I'll show you how that's done. So in this case, what I'm going to do is I'm going to take 228 divided by 360, multiply this by 2 times pi times the radius, which is 4. Now it's going to leave me with 228 over 360 times 8 pi. I'm not multiplying 3.14 or any of those decimal places through, okay? Now I'm going to take 228 and multiply it by 8. Think of this as like just multiplying across. So what's 228 multiplied by 8 going to be? Who could tell me? It's like a larger number. That's okay. It's like 1,000 something. Who's got it? Holly, you got it? Very good. 1,824. I'm going to leave pi here and divide that by 360. Now, all you need to do, you just need to focus in on this part. Forget the pi. Divide those two and then hit math frac. What do you get? So 1824 over 360, what are we left with as a fraction? Perfect. So I'm going to write down 76 over 15, and this pi just goes right with the 76. So there's your exact answer. You do not need to multiply by 3.14, okay? And honestly, the days of 3.14 or 3.15 or whatever the heck you used in middle school are over. If we're going to be multiplying this, we want to use as many digits as possible, so we'll use like the symbol pi in our calculators if we need an approximate answer. Okay? Questions on that? I want you guys to do the you try it and the practice on your own. We'll go over those in a few minutes. Again, be careful, leave it as an exact answer. Show of hands who's still working on these two. Anybody? Okay. Let's take a peek. All right, so you try it. You should have had 157 pi over 45. For practice A, you should have 160, B, 200, and C, 8 pi. Questions? Tomorrow we're in the companion. Today you have a delta math. Okay? Let's get going on the delta math and hopefully no homework tonight if you finish. Those of you watching at home, have a great day.